Hi guys, welcome back to Math 135. It's our first day doing actual class since we've gone online, so I thought I'd just give you a quick reading. Hello! Alright, let's get started. Today we are on 3.3 part 2. This is continuation of where we left off. If you have not yet downloaded the class notes, the ones I typically would pass out to you, then go ahead and do that. You can find it in Laulima under resources. Alright, so this is 3.3 part 2 again. We're going to start with the fundamental theorem of algebra. Before I explain anything to you, then pause the video and make sure that you read the first box where it says fundamental theorem of algebra. Alright, so all the theorem says is if I have some polynomial, remember polynomials, they basically have some number in front, some coefficient, right? And some x of different powers. The powers are all integer valued, right? And okay, this looks a little weird just because I have to be as general as possible, so we use letters, right? But really, this is just some number, x to some number lower than that, and we go all the way down until we have just a regular x, and at the very end, some constant number. Yeah, some number. All right, the only thing that I care about though for the fundamental theorem of algebra is what is this value right here? What's the highest power? We call that, by the way, the degree. Whatever the degree is, that's how many zeros the thing has. So there are n zeros for a polynomial of degree n. Now, those zeros, when we say n zeros, we mean complex zeros. They could be complex or they could be real. Of course, complex encompasses real too. Now, if the numbers are real, if those zeros are real, then what that means is it makes the function zero somewhere. So a polynomial will typically have a shape like this, right? And at the zeros, that's where it crosses the x-axis. So that's where the value is zero. Sometimes you can have a zero that's imaginary. So that's gonna look like this, where you have some turnaround in the polynomial function, and it actually does not cross. That's a complex zero because it's an imaginary number. But anyways, don't worry too much about that. All we care about is the fact that if I have a polynomial of degree n, it's got n zeros. Those zeros could be complex or they could be real. I bought this whiteboard especially for you guys, by the way, from Office Depot. But it's giving me a little problems because it's not fixed to the wall. Okay, I'm going to show you guys the first 3 questions as an example. And then I'm going to stop the video and move on to the next one. Okay. First question. Let me open up my notes real quick because I can't see the question. Hold on. Okay, the first question is f of x is equal to 3x minus 17. Before I show you the answer, as always though, pause the video, see if you can figure out yourself first. This guy, I have a x value which means the degree is just 1. You can think of this as x to the 1 power. So the degree is 1, that means there's just 1 0. That's it. And again, what does the zero mean? It means there's one value that I can stick in for x that's going to make this whole thing equal to 0. In this case, that would be 17/3, but that's besides the point. The question just asks how many, and there's 1. Second question, f of x is equal to 17x to the 7th minus 4x to the 5th, blah, blah, blah. I actually don't care about the rest of the function. All I care about is what is this highest power? It's a 7. Sorry, this 7 is hard to see. That's a 7. Let me write that one more time. That's a 7. That doesn't look much better, but okay, this is a 7, okay? Okay, so the 7 means the degree is 7. That means there are going to be 7 zeros. Again, those zeros could be complex, they could be real, or they could be some combination of real and complex. Now, when I say that it's complex or real, technically speaking, real values, complex numbers encompass all real numbers, so I could just say they're all complex, but to be more specific, some of them could be real and some of them could be complex. Does that make sense to you guys? I'm not sure if that makes sense. Basically, complex numbers include all of the real numbers. That's all I'm trying to say. All right, let's look at this last one. This is the last one. It's a little trickier, but really not too bad. It's x squared minus 2x plus 4. First of all, how many zeros are there? See, this is a 2. So there are going to be 2. And Actually, the question is asking for roots, but basically the same question. There are 2 roots. You can read about the difference between the language of roots and zeros in that box I wrote below, but essentially the same thing. Now, the follow-up question says, what kind of roots are there? So this is where they're asking, are they complex or are they real? If they're complex, then that means what's going to happen is it's going to have a discriminant that is negative. Do you guys remember how to solve these things for 0? Remember we had this quadratic equation, right? It was x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, if you look at this thing, it's got a square root, right? Anything underneath the square root, if that's negative, it's going to become an imaginary number. Remember that? It's going to have an I on it. If it has an I, that makes it complex. If it's positive, I can take the square root. It's not going to have any negative square root, so it's going to be a real number, normal real number. So what I want to know is if it's going to be a real number or if it's going to be complex. I just need to focus on this part right here to know. So let's look. B squared minus 4ac. In our case, that's equal to, let's see, negative 2 is b, square that, minus 4a is 1, the coefficient of x, and c is 4. So that's equal to 4 minus 16, which is negative 12. All right, so I have negative 12. That's a negative number. All I care is that it's negative. Negative means it's going to make this thing imaginary. So my roots are going to be complex roots. Right there. Now, if this had been a positive number or 0, then these would have been real numbers, square root of a real number, so that would have made both roots real. Okay, guys, that's it. I'm going to stop here and record the next video.